Hi ladies, in this video we're going to go through 5H and also 5I because 5H is very short and you need your knowledge of 5H for 5I. So I'm going to put them in this one video. First of all, we're going to cover identity and inverse matrices. So first of all, an identity matrix. As you can see here on the screen, we've got just two identity matrices. Basically, they have to be a square matrix, first of all. So that means 2 by 2, 3 by 3, 4 by 4, 5 by 5, whatever. As long as it's a square matrix. So your number of rows has to be the same as your number of columns. And an identity matrix also has ones going down the diagonal. So you can see in this example here, and this 3 by 3 example as well. Ones down the diagonal, and then zeros everywhere else. Now, an identity matrix is basically the same as multiplying something by 1. So when we're working with integers, so normal numbers, not matrices, basically multiplying something by 1, you have the same thing. So 5 times 1 is 5, 10 times 1 is 5. Here, when you multiply a matrix like this matrix here, A, when you multiply it by its identity matrix or multiply the identity matrix by A, so it doesn't matter the order that you're doing your multiplication, you're going to stay with A because the identity matrix is the same as multiplying something by 1. Okay, so you need to remember that. All right, moving on to an inverse matrix. Basically, the inverse matrix is what you multiply your original matrix to get the identity matrix. So when you think about the term inverse, when we're working with normal numbers like, let's say, 3, the inverse of 3 is 1 over 3. So when you multiply 3 by 1/3, you get 1. So your inverse is just what you get when you multiply an original matrix by its inverse, you get the identity matrix. So the same as when you're working with normal numbers, if you multiply 5 by its inverse, which is 1/5, you get 1. So 5 times the 5th is 1. In matrices, when you multiply a matrix by its inverse, you get its identity matrix. Okay, and remember the identity matrix is the same as 1. Now, at this point, you don't need to know how to calculate the identity matrix because you can do it easily in your calculator. So I'm just going to bring the calculator up here. All right, and let's put in a matrix. And I'm sorry, I didn't realize when I put, oh, that's a bit better. Now it's going to fit in. When I did my screen that everything wasn't going to fit in. Okay, let's put in a matrix and I'm going to make one up. Okay, so there's our matrix. If you want to, you can store it. I never really do. So inverse is to the power of -1. Okay, and there is your inverse. Now, remember what I said before, your matrix, so in this case, this matrix here, multiplied by its inverse will give you the identity matrix. So let's prove me right or wrong. So I'm going to just do that again, get rid of that power to the -1. So remember, the matrix multiplied by its inverse gives you the identity matrix. Okay, it's the same as if, and I was saying before, any number to the power of -1, you'll get its inverse, which is 1/5, and 5 times 1/5 gives you 1. Okay, so if I just scroll back up here, your matrix multiplied by its inverse will give you the identity matrix. And that's true for any size matrix. Okay, so you can get a 3 by 3, a 4 by 4, take the inverse and multiply it to get the identity matrix. All right, let's move on to do some questions. There's instructions there on your calculator, but it's not difficult. I just showed you. Okay, so we've got two examples here. All right, very easy. Let's just quickly do it on the calculator. So what have we got? Oops, that's not what I wanted. Sorry. That's what I get for not looking. Okay. Start again. What was it? 5, 4, 3, 1. So remember, pressing tab means you quickly move. Don't use your arrows here. They're not as user-friendly. To the power of -1. And there's your inverse. Now, I strongly encourage you to leave it as a fraction. Don't write it in decimals. Okay, so leave it as a fraction. In case you need to do something with it, it's always better to leave it as a fraction as opposed to a decimal that you might round and you'd get the wrong answer. All right, let's do the next one, 3762. Just make sure I choose the correct program to open. What was it, 3762? I hope so. I hope my memory is good. To the power of -1. And there's your inverse for that matrix. Oh, I didn't do 3, 6. Oh, no, I did. Good. Okay, moving along. And there's only 2 questions there. Okay, so as long as you understand what an identity matrix is, what an inverse matrix is, and how they relate, you're good. All right, let's move on to 5i. So encoding and decoding. This is interesting because it's not actually on the further maths course. So when I saw this, I was like, this is new and a bit interesting. So basically, you can use matrices to set up codes. Okay, you can set up the encoding and decoding. So setting up codes, so you can give messages using some code, and then you give the encoding matrix, so how you got the coded message, and then you can use the inverse to decode the matrix to get the message. Okay, seems a little bit obscure, and I thought at first that it was, but it's quite easy to understand. So in this example, and this is just an example, it's not always true. Okay, so we're assigning numbers to letters. So you can see here, letter A is the number 1, right up to Z, 26, and then we have 27 for spaces. So let's say we wanted to send to our friend the word or the message, meet me. Okay, so you can see we've got 2 rows, and the word meet has 4 letters, me has 2 letters, but we've got 2 spaces. So we've got 2 rows, 4 columns. All right, so here's our message matrix here. So, and I was just about to point to the screen, isn't that weird, with my finger, because you can all see me pointing. Oh, that's hilarious. Okay, so the number 13 corresponds to M. The number 5 corresponds to E, so that's just meet space me. Okay, so there's your message. Now, we're assuming that you don't have this coded thing. So what we're going to do to encode the message, we multiply it by this matrix here. So this matrix changes depending on whatever the code is, okay? So this is all made up stuff. It's not true for every coding problem. Okay, so if we're encoding this message, we multiply it by this encoding matrix, matrix C, so you can see that up here, and then we multiply that by our message, and we get this matrix here, which we call CM, C times M. And then you might give that message to a friend. You give the encoding matrix, and to decode it, you multiply it by its inverse. Now, the reason we do that, remember, your matrix, your original matrix multiplied by its inverse gives you 1. Okay, so we're basically undoing this matrix, and then we're just left with our answer, okay, the meet me. All right, so you can see there, that's our original. Now, let's have a look at a few examples. So, as we all know, maths rocks. So let's get the calculator up. And before I do that, let's think about how many rows and how many columns our matrix is going to have. So we've got 2 rows, okay, 2 words, 2 rows. You can put both words on one row, but here we've got 2 rows and we've got 5 columns, okay? So in our matrix, I tell my calculator that I want 2 rows, 5 columns. Okay, and then we just put in the letters. So remember, if we scroll up here, we're going to use this coding system. Okay, so your letter M is the number 13. Now this is already in the textbook, so I'm going to just have it out with me while I've got the calculator here. So the letter M is 13, A is 1, T is 20, H is 8, S is 19, and then we've got rocks down the bottom, so we've got 18, O, 15, C is 3, K is 11, and what was our last letter? S, 19. Okay, so, oops, didn't press tab. There's our matrix, Maths Rocks. Now, we're using this matrix here, the encoding matrix, the same one as before to encode that message. So 2, 3, 1, 2. Let's just get to the calculator. 2 by 2 matrix. Oh, I've already forgotten what it was. What was it again? 2, 3, 1, 2. Okay. 2, 3, 1, 2. And we're multiplying, so I'm just going to put the multiplication sign in there. And there's our encoded message. So we send that off to, you know, our lover who's gone off to war, or our friend, whatever. So this is the encoded message. They get this message and then they say, oh, okay, I'm going to take this original matrix and I'm just going to, So you can Shift and Control C, girls, if you just want to copy and paste. Okay, so Control C to copy, Control V to paste. To the power of -1, so your inverse. And then we multiply that by our message. So our friend or whoever will get this message, they will decode it, and they're like, oh, meet me, awesome. Okay, so there's another example down the bottom. All right, you can do it if you like. I'll give you the answer. I think it was something like ship sails tonight or something like that. I did it earlier and I thought, what a boring message. So if you want to go ahead and do it, it's something like ship sails tonight. I think there's another word maybe at the end, but you can see that the good thing about using codes is the same letter. So if you can see, none of these numbers is repeated. So, oh, well, there's 2 44s, but it's not corresponding to the same letter. Okay, so if we go back to this previous example, the meet me, let's go back down. The coded message, the CM, you can see the 2 E's are not the same. So, you know, you can kind of be sneaky like that. All right, so moving on, the two questions. 2 questions from 3H, and then I've scrolled too far, haven't I? Sorry. Your 2 questions from 5I, your questions from 5I are 1 to 4. All right, girls, I'm going to stop now before I keep making mistakes. Bye.